Embark on a journey beyond the realms of conventional science as we delve into a realm of speculative theories that challenge our understanding of the universe. From the enigmatic great filter to the mind-bending concept of nested simulations within simulations.
Welcome to PathtoFacts, where mysteries are solved and wonders are revealed. Today we'll delve into a world that's right under our noses, yet still full of surprises.
1. The Great Filter. The Great Filter theory speculates on why, despite the vastness of the universe, we have yet to encounter extraterrestrial civilizations. It proposes that there may be insurmountable challenges or filters that intelligent life must overcome in order to advance to a certain level of development. These filters could be biological, environmental, or existential in nature, and they could act as bottlenecks that significantly reduce the likelihood of civilizations advancing beyond a certain point. The implication is that either we have already passed through these filters relatively unscathed, which is rare, or there are formidable obstacles awaiting us in the future, which may explain the apparent absence of advanced extraterrestrial civilizations in the cosmos. 2. Time warp hypothesis. In the realm of speculative physics, the concept of time loops challenges our conventional understanding of time as a linear progression from past to present to future. Instead, this hypothesis suggests that time could form closed loops, allowing for events to repeat endlessly or for time travelers to influence past events without causing paradoxes. The idea draws inspiration from science fiction and quantum mechanics, where concepts like closed time-like curves and quantum entanglement hint at the possibility of nonlinear temporal dynamics. While still firmly in the realm of speculation, the time loop hypothesis raises intriguing questions about the nature of causality, free will, and the fundamental structure of reality, and offers a startling alternative to traditional views of time. 3. Digital physics. Digital physics proposes that the universe functions like a vast computer simulation, with reality governed by algorithms or mathematical equations, much as computer programs generate virtual worlds. This theory draws parallels between the behavior of complex systems in nature and the computational processes found in digital systems. Proponents of digital physics argue that this perspective could potentially explain various phenomena in physics, such as the discrete nature of quantum mechanics or the fine-tuning of physical constants, by viewing them as emergent properties of a simulated reality. While speculative, the idea of the universe as a digital construct challenges our intuitions about the nature of reality and raises profound questions about the ultimate nature of existence. 4. Biocentrism. Biocentrism suggests that consciousness plays a fundamental role in the universe and that the existence of the cosmos depends on the presence of observers, implying that reality is subjective and shaped by perception. Proponents of biocentrism argue that the universe exists only as a construct of our minds, with space, time, and the laws of physics emerging from our consciousness. This theory challenges the traditional view of an objective reality that exists independently of observers and suggests a more intimate relationship between consciousness and the cosmos. While controversial and difficult to test empirically, biocentrism raises profound questions about the nature of reality and our place in the universe. 5. White holes. While black holes are well-known cosmic phenomena, some theorists propose the existence of white holes, which are hypothetical regions of space-time that expel matter and energy rather than consume them, essentially the opposite of black holes. According to this idea, white holes would represent the endpoint of the process of gravitational collapse, where matter and energy are ejected outward instead of being pulled inward. Although speculative and not yet observed, white holes raise intriguing questions about the nature of space-time and the possibilities of general relativity. If confirmed, they could have profound implications for our understanding of the dynamics of the universe and the fate of matter falling into black holes. 6. The universe as a giant brain. This speculative idea suggests that the structure and behavior of the universe resembles that of a giant brain, with galaxies and other cosmic structures mirroring neurons and neural networks, possibly implying a deeper connection between the cosmos and consciousness. Proponents of this theory draw parallels between the way information is processed and transmitted in the brain and the way matter and energy interact on cosmic scales. They argue that just as neurons communicate and form complex patterns to produce consciousness, cosmic structures may interact in ways that produce emergent properties of the universe. While highly speculative and metaphorical, the idea of the universe as a giant brain challenges our conventional understanding of consciousness and raises profound questions about the nature of reality. 7. The holometer experiment. The holometer experiment aims to test the hypothesis that the universe is pixelated at the smallest scales, similar to a hologram, with space-time composed of discrete units rather than a continuous fabric. By measuring the quantum jitter of space-time caused by fluctuations in the fabric of reality, the experiment aims to determine whether there is a fundamental limit to the resolution of space-time. If successful, the results could provide evidence for theories proposing a holographic nature of the universe, where information about three-dimensional objects is encoded on a two-dimensional surface. Although still in the experimental stage, the holometer experiment represents a bold attempt to probe the fundamental structure of reality and could potentially revolutionize our understanding of the cosmos. 8. The electric universe. Proponents of the electric universe theory propose that electricity and magnetism play a much larger role in the structure and dynamics of the universe than conventional models suggest, with electric currents shaping galaxies and stars. According to this view, cosmic phenomena such as star formation, galaxy rotation, and even the behavior of black holes can be better understood by considering the electrical interactions between celestial bodies. While mainstream cosmology acknowledges the importance of electromagnetic forces in certain contexts, the electric universe theory posits a much more pervasive role for electricity in shaping the cosmos. While controversial and not widely accepted in the scientific community, the electric universe theory offers a provocative alternative to traditional cosmological models and invites further investigation into the role of electromagnetism in the universe. 9. The omega point. The omega point theory, proposed by physicist Frank J. Tipler, posits that intelligent life will eventually evolve to a state where it can manipulate the entire universe, leading to the resurrection of all individuals who have ever lived, effectively transcending space and time. According to this idea, advanced civilizations could harness the energy and resources of the cosmos to create a simulated reality in which all sentient beings could be resurrected and live indefinitely. Drawing on concepts from physics, theology, and futurology, the omega point theory envisions a future in which humanity achieves godlike powers and realizes its ultimate destiny. While highly speculative and controversial, the omega point theory offers a thought-provoking vision of the future evolution of intelligence and its potential implications for the nature of reality. 10. The simulation within a simulation hypothesis. Taking the simulation hypothesis one step further, this theory proposes that if our universe is a simulation, then the beings creating our simulation could themselves be part of a higher-level simulation, leading to an infinite regress of simulated realities. According to this idea, the simulated universes created by advanced civilizations could themselves create simulated universes, forming a nested hierarchy of simulated realities. Each level of simulation would be governed by its own set of rules and inhabited by conscious beings who could create simulations themselves. While purely speculative and difficult to test empirically, the simulation within a simulation hypothesis raises intriguing questions about the nature of reality, consciousness, and the possibility of infinite regress in the hierarchy of existence. Explore intriguing universe theories? Like subscribe, share, comment, and keep discovering.